Hey guys, it's Mr. G, Mr. Wells, and today we're going to start the video on Unit 7, Day 1. Right now we're working with systems of equations. So what we want to do is we want to find out the values for both variables of y and x. So as you can look at practice problem number 1, we have it so y actually equals two different expressions. So we have y equals 2x minus 3 and y equals 3 minus x. Now the great thing about this one is that whenever you have a single variable equaling two different expressions, we can just set them equal to each other. So if y equals 2x minus 3 and y also equals 3 minus x, I can just set them equal to each other. Alright, and now it's just a good old-fashioned equation, and I'll just draw my river. I have more variables over here, numbers over there, move some things around. I'll do a plus 1x here, plus 1x there, get my 3x, that cancels out. I'll add 3 here, add 3 there, that cancels out. I'll set it equal to 6, divide by 3, and I should get x to equal 2. Now don't think that you're done right here, because like I said, we want to get the values of both variables. So since I know that x equals 2, you know the song that I like to sing you guys, just plug it in, plug it in. I'm going to use the easier one. I'm going to use this one because it's pretty cut and dry. If y equals 3 minus x, and I know now that x is 2, I'm just going to plug it in. So y equals 3 minus 2, y equals 1. So make sure when it's all said and done you have values for both variables.
Alright, so for... There we go. Alright, so for number 4 here, move this over. There we go. This time we have x equaling 2y minus 1. And then the second expression here says 2x plus 3y equals 47. So we don't have x alone twice this time, so it's a little bit different. We know x equals 2y minus 1. So what I'm going to do with that 2y minus 1 is I'm going to use it and replace x in the bottom equation with 2y minus 1. So instead of writing down 2x here, I'm going to write down 2 and replace that with 2y minus 1, because we know that x is 2y minus 1, so we're just changing that. And then I'm going to copy the rest of the equation down. Plus 3y equals 47. Fix my plus sign there. And then I've got an equation with just one variable in it. The x is gone, so it's just y. So it's just a good old-fashioned step 5 equation, or 5-step equation. So we distribute here, I get 4y minus 2 plus 3y equals 47. So I'm going to combine my like terms. A 4y and a plus 3y is a 7y minus 2 equals 47. If I add 2 to each side, that gives me 49. So 7y equals 49. That's a y. I'll move this up a little bit so we have a little more room. And then if I divide both sides by 7, I see that y equals 7. Now, once again, systems of equations. 2 equations, we need 2 solutions. So we have y. We still have to plug in and find out what x is. I'm going to find out what one of these equations was. That top equation is pretty easy. X equals 2y minus 1. So if x equals 2y minus 1, and I know that y is 7, I can just plug in 2 times 7 minus 1, which is 14 minus 1. So we know that x is 13. And we have 2 answers for our system.